Hi and welcome back. So in the previous video we introduced our chapter 9 of our macroeconomics 3 module, and we basically introduced the concept of bond prices and bond yields. So the last part of our previous session was basically to explain the arbitrage concept, and we concluded that the arbitrage implies that the price of the 2-year bond today is the present value of the expected price of the bond next year. What we had and answered very thoroughly is the question that what does the expected price of the 1-year bond next year, which is represented by this fraction, depend on. And this is where we're going to start off in this video. So what does the expected price of 1-year bond next year depend on? So the answer to this is quite straightforward. Just as the price of a 1-year bond this year depends on this year's 1-year interest rate, the price of a 1-year bond next year will also depend on the 1-year interest rate next year. So writing equation 15.1 for next year will mean adopting denoting the expectations in its usual form, meaning that now we denote the payment, the price of the bond expected next year by its expression of expectation instead of the actual payment this year, the known payment, as we did in 15.1. So this would mean that now the price of the bond next year is expected to equal the final payment, which is the 100 Rand, that is the final payment in the end of the term, discounted by the 1-year interest rate expected next year. So we simply discount the full payment by the expectation or the interest rate that is expected next year. So if we replace the expected bond price for next year by its expression of this in equation 15.4, this is what we get. So equation 15.5 simply tells us that the price, the 2-year price, or rather the price of a 2-year bond is equals to the full payment of the bond divided by, or rather discounted by the interest rate of this year and the next year, which is the interest rate over the 2 years. So this equation is same as equation 15.2 if you would look at it clearly. So this suggests that the arbitrage between 1 and 2-year bonds imply that the price of the 2-year bond is equals to the present value of the payment in 2 years. That is the present value of 100 Rand, discounted using the current and next year expected 1-year interest rate. So this is clearly shown by equation 15.5. So the price of a 2-year bond is equals to the present value of the payment in 2 years. That is the present value of 100 Rand discounted by the current and next year's expected interest, the current interest rate and next year's expected interest rate. Now that we've looked at the bond prices, we are now ready to go on to bond yields. So the basic point here is that bond yields contain the same information about future expected interest rate as bond prices. They just do it in a much clearer way. So the starting point of this will be to define the yield to maturity. So the yield to maturity of an N-year bond, or equivalently an N-year interest rate, is defined as the constant annual interest rate that makes the bond price today equals to the present value of the future payment of the bond. So this definition is quite simpler than it actually sounds. Take, for example, the 2-year bond we introduced earlier. Denote its yield by I2, as shown here. or I2T, where the subscript 2 is there to remind us that this is the yield to maturity on a 2-year bond, or equivalently 2-year interest rate. So following the definition of the yield to maturity, this yield is the constant annual interest rate that would make the present value of the 100 rand, which is the final payment in 2 years, equal to the price of the bond today. This then satisfies this relation that the 2-year the price of a 2-year bond is equals to the final payment discounted by the interest rate over the 2 years. So we are going to use this equation 15.6 and equation 15.5 to get the relation of the 2-year interest rate to the current 1-year interest rate and the expected 1-year interest rate. So eliminating the price or the price of a 2-year bond from the equation 15.6 and 15.5, this is what we get. So this is from 15.5 and this one is from 15.6, which are both equals to the 2-year price of the bond. So it means that they are both equal, and this is what we get. And if we rearrange this equation, it gives us the exact relation between the 2-year interest rate, which is this I2T, the current 1-year interest rate, which is this one, as well as the next year expected 1-year interest rate, which is given by the last part of the equation. So this simply say the 2-year interest rate is equals to the current interest rate, or rather is influenced by the current interest rate and the interest rate expected next year. And a useful approximation of this relation is given by equation 15.6. So equation 15.6 says the 2-year interest rate, which is this, is approximately the average of the current 1-year interest rate and next year's expected interest rate. In actual fact, this should be an approximation, not equals, but it basically suggests that the 2-year interest rate is approximately the average. That's the average of the current interest rate and next year's expected interest rate. So in our example, we have focused on the relation between the price and yield of 1-year and 2-year bonds, but our results generalize to bonds of any maturity. For instance, we could have looked at bonds with maturity of less than a year, or even at bonds of over 10 years. So just to make an example of one that is less than a year, we would say the yield on a bond with the maturity of 6 months is approximately equals to the average of the current 3 months interest rate and the next quarter's expected 3 months interest rate. Or we could have looked at instead at a bond with the maturity longer than 2 years. For example, a yield on a 10-year bond equals, or rather is approximately equals to the average of the current 1-year interest rate and the 1-year interest rate expected for the next 9 years. But the general principle is clear. Long-term interest rate reflects current and future expected short-term interest rate. So this relation tells us how we can interpret the slope of the yield curve. So to do so, let's examine how yields can be interpreted using the information we just covered. So by looking at the yields for bonds of different maturities, we can infer what financial market expect short-term interest rate will be in the future. So suppose we want to find out, for example, what financial market expect the 1-year interest rate to be 1 year from now. All we need to do is to look at the yield on a 2-year bond, which is represented by I2T, and also the yield on a 1-year bond. So from equation 15.7, multiplying both sides of 15.7, which is this equation here, multiplying both sides by 2 and reorganizing, we get this relation. So relation or equation 15.8, which basically tells us that the 1-year interest rate expected for next year is equals to twice the yield on a 2-year bond minus the current 1-year interest rate. So which is shown by this. So now this is this is an equation or relation that shows us how to generate or work out the expected interest rate next year. So given this equation, you can calculate both long-term and short-term interest rate. So this relation basically tells us that we can now simply interpret the yield curve in such that when the yield curve is upward sloping, that is when the long-term interest rates are higher than short-term interest rate. It tells us that financial markets expect the short-term interest rate to be higher in the future. But when the yield curve is downward sloping, and that is when the long-term interest rates are lower than the short-term interest rate, it tells us that financial markets expect short-term interest rate to be lower in the future. Okay, so this is where we end bond prices and bond yields. So in the next video, we move to the market for shares and look at the share market and movement in share prices. All right, thank you.